Okay, I thought I'd take a couple of seconds just to run through what we were doing today in ratio, just in case, you had a little trouble thinking your way through it and you wanted to make sure you had an opportunity to see it one more time. So when we talk about ratio, a ratio is a way of comparing amounts, just as we see here. And in class, I mentioned the whole idea of, say, 12 of us decided to choose what we wanted to eat, either on barbecue day and we decided to have a hamburger, or on pizza day and you decided to have, the cheese and pepperoni pizza. So there were 12 students, 5 chose pizza, and 7 chose hamburgers. And in class, we said that the ratio of people who would choose pizza to hamburgers was 5 to 7. Now, mind you, it could also be 7 to 5 too, because if you were saying the ratio of people who chose hamburgers to pizza, it depends on how you put the words in and in what order you use them, could be 7 to 5 as well. And we also said that if we had 24 people in the class deciding to choose either hamburgers, pizza, or for you to bring your lunch from home, that it would be 1 to 1. It would be 12 students would have chosen that. 12 students and me would have chosen to bring their lunches in, and 12 students would have chosen not to. So that was just an idea to get us into the mindset to do actual ratio. So when we went a little deeper than that, what we started looking at was doing a paint job. Okay, so we started talking about how we would actually do a paint job on a shed, and we started talking about direct proportion. And what we were talking about with direct proportion was this. Okay, direct proportion is when 2 quantities are in the same ratio. Now, whether you're talking about colors of paint or you're talking about recipes, like the recipe for the buttermilk pancakes we were talking about, when 2 quantities increase and decrease in the same ratio, they're in direct proportion. So 1 cup of cake flour to 2 cups of milk for a recipe for pancakes is a 1 to 2 ratio, and that doesn't change. If you do 2 or 3 recipes, the amounts might change, but the ratios stay the same. So to give an idea to that, the example that's given is mixing red and white paint to paint a shed. So to get the color that's wanted, you needed 4 red paint buckets to 1 white paint bucket to get the color that they were looking for. Okay, and that wouldn't change no matter how much paint you needed. So in other words, if I needed to paint 2 sides of the shed, I'd need 4 red and 1 white. But if I wanted to do all 4 sides of the shed, it wouldn't change. Okay, what you'd end up with is the same proportions again: 4 to 1 to do 2 sides, and 4 to 1 to do the other side. Okay, the other 2 sides. So in other words, what you would end up doing is staying proportional. Okay, to double the amount of paint, you'd have to double the amount in the same ratio to stay with the same colors. Okay, so there we go. If you double the amount of red paint, we have 8 cans, and you double the amount of white paint, you have 2 cans. So in other words, in the long run, what you're really looking at is, if you wanted to do all 4 walls of the shed, you'd need 8 cans of red and 2 cans of white to stay in direct proportion. You're with me so far? Good stuff. All right. So let's get an idea of some of the ways you can play with this a little bit, okay? So we're going to do some ratios and see if we could figure out which ones are in the right columns. We did this in class too, and we worked it all the way through. 5 to 10 is the same thing as 1 to 2. Makes sense. 5 times 1 is 5. 5 times 2 is 10. That's where you get to 1 to 2. 4 to 2 is the same thing as 12 to 6. Same reason. If you multiply both sides by 3, you get the numbers on the other side of the equation. 1 to 6, 3 to 1, to 9 to 3. Again, all the same idea. But if they're not in direct proportion, what you get is it doesn't match up. 1 to 2 can't be the same as 2 to 3. Because to get from 1 to 2 in the beginning of the ratio here, on the left-hand side of the ratio, to get from 1 to 2, you're multiplying by 2. 2 to 3 is not multiplying by 2. It's multiplying by 1 and 1/2. So you end up getting something that's not in direct proportion. Same thing here. 1 to 4 should be the same thing as 4 to 16. See what I'm getting at? Because you'd have to multiply that 1 by 4 to get to 4. Then you'd have to multiply that 4 by 4 again to bring it up to direct proportion. All right. So far, so good. Let's take a look at some of the questions we were looking at. A factory makes 5 bicycles per hour. How many bicycles can they make in 2 hours? Well, you multiply the 5 times 2. Makes sense. It's in direct proportion. 1 chocolate bar costs $1. How much would 5 bars cost? Well, 5 times 1 is $5. Direct proportion. A taxi goes 10 miles in 20 minutes. How far does it travel in an hour? Same kind of story there as well, okay? A couple of them more difficult because it's easy when you're multiplying, but when you have to think of how to take the step back and do the division part, it might get a little complicated. Sue can do 20 math questions in 5 minutes. How many can she do in 1 minute? 4, because you divide 20 and you work it on down, okay? 4 packs of candies would cost $4.50. How much would 2 packs cost? $2.25. It's half. And a city bus goes 18 miles in 30 minutes. How far does it go in 10 minutes? Well, you divide by 3 because 10 is one third of 30. So 1/3 of 18 is 6. All right. And just to give you an idea, I'm going to let you take a look at some of the answers to the questions. There's 10 bikes, $5. Okay. 30 miles. So far, so good. 4 questions, $2.25, and 6 miles. Okay. So that's a quick rundown of what you do with ratio. Look for the questions for tonight's homework and see if you can work it out and get a better idea of exactly where to go with this. All right? Thanks.